Hi everyone, good morning. I'm going to leverage the slightly smaller area of the room here and get some direct feedback from people by looking in their eyes to engage, how well I'm doing in real time. My name's Josh. I'm the co-founder and chief technology officer at Measurable.energy. So my background and my passion is in sort of embedded electronics and hardware systems. And then I went on to do a PhD in machine learning labeling systems, which was less of a passion, but I'm glad I did it. And my sort of whole career has been trying to fuse those two things together to generate some value for someone somewhere. I've always been passionate about sustainability, and I wanted to sort of put my money where my mouth was, in a sense. So I have done this, and only this, for my entire career. So that is the sort of length and breadth of my experience is in measurable energy. So keep your questions contained to that, or personal matters. Yes, fab. So I'm going to focus on, today, I'm going to focus on small power. Does everyone here know what small power is? One. Fab. Okay, good, fab. So we've got to talk a little bit about small power, the problem with small power, and then I've tried to sort of make this a bit more of in a construction tact rather than the general commercial buildings vibe, to hopefully make it more, comment appropriate, but it does apply to any commercial building. But just to be clear, not domestic buildings, just commercial buildings. So, if you want to scan the thing, feel free. Fab. Right, so we're going to talk about eliminating small power, specifically waste, which is an important sort of addition to that, in commercial buildings, and we're going to do that using the measurable energy platform, which we've developed and have been working on since 2018. So we'll start by assessing the nature of the problem here. So this graph shows that the energy breakdown of a commercial building. Has anyone ever seen this graph before? So we'll play a game. Does anyone guess how energy in any given commercial building is broken down? I'll give you a massive clue to start with. Other. Yeah. So basically, we break down commercial buildings' energy into three main categories. So lighting, it's pretty obvious. And lighting's been tackled aggressively for the last 20 or so years with the introduction of LEDs, which is a relatively simple idea, a technology that produces the same amount of light for less energy, swap them out, jobs are good 'un. And central controlling systems like PIR sensors and ways to turn off the building remotely. The other one, HVAC, big one, obvious one. So that's heating, cooling, air management. Over the last 20 odd years, fantastic improvements there, which have been mainly due to centralized control. So rather than having room level controls of yesteryear, it's usually controlled by a building or facilities manager centrally and optimized as such. But the constant improvement in those two spaces has actually made the last one, small power, not small anymore, which it used to be. And small power is essentially everything else that's electrical. So anything plugged into a socket or wired into a fuse spur is small power. So in this room you're looking at here, we've got the lights here, but you see the speakers here, the equipment, all of this is all small power. And historically it's been ignored because A, it was small, and B, it was almost impossible to control because you'd have to control it at the outlet level, of which there are lots of. And also it's difficult to measure the impact of what you're doing, and the use cases are so varied that it's impossible to understand what people are doing with it. But the big problem with small power, which shocked us as well, is that blurry? It is. Okay, half of small power is waste. That's the take-home message here. So half of all small power is waste. So basically 20% of every single commercial building is just bleeding away into wasted small power in a system that is unmonitored, unregulated, and uncontrolled. Unlike the others, which have significant investment behind them, small power is just largely ignored. So the solution that we're trying to work on here is we're going to use AI, machine learning. I don't really like the term AI, but machine learning is identify what people have plugged in, measure what they plugged in, and then turn it off. So it's quite simple. If you're not using it, it should be off, but we don't expect people to do that. We often sort of joke that our next best competitor is a poster by the door that says, "Have you turned off your TV?" And by the time you've got down to the ground floor and you're like, "Oh, did I?" I don't know, you walk out. Everyone does it. They've done it for years. That's not going to stop. So a solution has to come in to help people achieve that. So that's what we built. We built the measurable energy platform. So this is our first product here. So it's a standard like-for-like swap-out socket for your a two-gang socket you'd see anywhere. This is a smart socket. So this socket is enterprise-grade smart socket. So you may have seen something similar on Amazon where you can get a plug-in device that you can talk to with Alexa that turns off. This does the same thing, but it's designed for enterprise. So it monitors energy on every single channel and sends it back to our cloud, which you can access anytime. And it also can turn off any given channel at any given time as well. And so the idea here is the automated part of it. So not sitting there setting up schedules on thousands of sockets in a building, but automating it. So the way we do that is by monitoring the energy patterns for every single socket, automatically determining what's been plugged in, and then determining the use pattern over time, and then automatically optimizing it by turning off at periods when the device is not being used. That's the objective. So another thing we've added to it as well, this is more of like an engagement piece. We often talk about how with small power, there's a cultural problem as well. So the analogy that we like to use is that if you went to a stranger's home and they invited you into the kitchen and then they popped out for a second and you saw the tap was still running, you'd absolutely feel just empowered to go and turn it off. Because it's visual, it's audible, it's being wasted, that's wrong, turn it off. But if you were in their living room, would you feel empowered to go and unplug their TV because you notice it's in standby? You just wouldn't do it. It's the same kind of problem. We're really struggling with like a notion of what is and is not okay. And typically it's the same thing in public spaces. If you see a socket in a public space, you just, oh, I'll take that, yeah. You don't think about how much you're using it, who's paying for it, where it's coming from, how much carbon it's burning. It doesn't enter our minds, it's just, let's just take it. And on a one-by-one scale, this really isn't a problem, but it's a massive problem when it all adds up. But the hard part is like building those pieces together to form the whole. So what we did is we show on our sockets here a spectrum on the light at the front here. It's also with our fuse spurs as well, you can see there. Then the spectrum goes from red to green, so this links directly to the National Grid's energy API interface, which shows you how dirty the energy is in real time. So every 5 minutes, it'll show you how dirty the energy you're taking is out of the grid. So if all the clouds go over, the rain comes down, and the wind stops, then we start having to like fire up all the gas. It'll go red, but then the clouds part, so the solar panels come on again, the wind picks up, it'll go green again. The idea is to sort of engage a bit of behavioral change with people. So, oh, it's green, I'll plug in my phone to charge it, or, oh, it's red, I'll unplug my, etc. But we can also automate this as well. So you can just set it so you can basically say when the carbon is high enough, do this, or when the carbon is low enough, do this. So for example, charge all the laptops in the building if the carbon is above this or below this. We've seen use cases for that so far. So that's sort of the hardware piece. So what kind of savings can we achieve with this technology? So in sort of the office real estate, we've actually seen that we can see up to a 53% energy reduction. And it's not like that's not a poster child number that we put there. It's actually the numbers we have higher than that, which we decided to hold back on. It doesn't sort of seem so ridiculous. We have seen some scenarios where we've seen 69% reduction in energy just by implementing this system. We do charge for the service as a hardware piece, but also as a software as a service piece. So a core tenet of what we do is it must provide value financially before it provides sustainable value, because unfortunately that's just the world we live in. People care a lot more about the payback period than they do about that. And so this is a relatively low cost technology that in this case can provide an average of 10 months payback in the office real estate market. Educational market, same sort of vibes, but 14-month payback. And there are other sort of sectors that we work in as well. But actually, what we didn't expect when we started the company was our biggest vertical, which is tier 1 site accommodation. So that's in the construction industry. So the construction industry, they sort of took it on. We didn't realize why at first when a few customers started taking it on for their sort of welfare offices or for their site offices. But they've seen a massive, massive reduction really quickly. And there are lots of reasons for that. So I'll get into that quite quickly here. So same graph as before. This is the problem you have in site accommodation. So site accommodation's HVAC systems are rare, or they basically get swapped over back into small power. So if you think radiators on the walls start becoming fuse spur electric radiators rather than central heating systems, and suddenly that becomes a small power problem. So you're seeing most of these sites are completely electrified, which means that the problem expands greatly. And at the same time, the problem gets even worse because lots of them are powered by diesel generators as well. They're not plugged into the grid. So the carbon intensity of their energy is off the charts and the cost is incredibly high as well. So they're highly motivated to do something about that. So we come in with a simple idea and we turn it off. So one of the big sort of areas of waste you see in these sites are drying rooms. So when construction workers get wet, they take off their stuff, they put it in a drying room. The drying room is basically a dedicated room filled with heaters that are on all the time, just to dry things as and when it's necessary. And if you want to cool the room down a bit, because it's getting a bit hot in there, you simply open a window and that regulates the temperature, which is high tech and it works. But again, if you were to ask these people to do something about it, realistically you're asking them to like reach up to a fuse spur and how does it work? They're not going to do it, and that's fine. I wouldn't expect them to. So we've got to automate the system. So when we first started out, one of our pilot case studies was in a drying room, and because we are an internet-enabled device, we're part of the Internet of Things network, we simply just hooked it up to the weather forecasting API, which meant that we could just only turn it on when it was wet, and that's it. So we operate in a hierarchical system, so you can set up, how the sockets operate from the top level down. So when you say the building will turn off at this time, the building will turn off at this time. But because we know what devices are plugged in where, we can automatically shield devices from this sort of brute force approach. Because some people often say, well, why don't you just go and flip the fuse box, just turn that and kill the whole floor. But what it also kills is the Wi-Fi, it kills the fridges, it kills all sorts of other important equipment that needs to be on. And so they go, okay, well, we either have to rewire the entire place to have a separate fridges switch, or we have to go off and turn individual, it's a non-starter. So because we can detect a Wi-Fi repeater, a Wi-Fi device, we can detect a fridge, we can detect other equipment. You can also set it up so you can shield equipment manually. It'll turn it all off. We also implement these buttons on the front here that allow people to get energy when they need it. So if you approach a socket that's off in your building, so let's say it's 9 o'clock at night, you've come back in and you need to do some last minute work, but the office is off, you can press the button and it will always turn on. And we call it an hour of power. It's actually 2 hours of power, but it doesn't matter. The idea is similar to that in like a toilet in a public bathroom where you push down the plunger and it gives you like 10 seconds of water. And it's frustrating at first, but the idea is to stop you accidentally leaving it on and running a tap overnight. So we'll give you 2 hours of power, but because you are on the ground floor, so we've got all the fancy algorithms to detect when someone should or should not be there. But if you're there, you're at the ground, you know you need that energy, it's stopped being defined as waste at this point. It's now energy you need, and so we will supply it. So anywhere on our network, if you see a button, you press it, it will deliver power to you. It's still recorded, of course, and we recorded this information that we can send out. And it also helps us label as well, because if we've been a bit aggressive with our algorithm and we've turned things off a bit too early and you see a lot of button presses, we can just simply nudge it back and open it up again so we can perfectly optimize this system. So a couple of case studies just to leave you with. So this is Kia Group. So Kia Group make a lot of cabins of it. Well, they don't make cabins, but they use a lot of cabins. And so this is one of our first ever deployments we had there. So we've got a 6-month payback. We avoided 3.8 tons of carbon and saved them £3,000. So again, there's not much detail to it other than we just turned stuff off when it shouldn't have been on. That was about it. So that expands out to the entire cabin market, just approaching that Kia and another one of their sort of subcontracting customers. It's not a small amount of it. It's £1.7 million a year for them. It's 2,177 tons of saving per year of greenhouse gases as well. So yeah, that's the overview of the system. So in short, what we do is we just automate a problem that has resisted any interaction with people because of how difficult it is to automate. So that's what we've approached. So we're rolling out, we've been going since 2018, and that was like a proper sort of man in the shed operation. So I hand-made the first 250 sockets in my bedroom by hand, which was exciting. So and we rolled them out and we got some really good feedback from those, just to primarily prove that these numbers were true, because when we first heard them, we were like, there's no way, 20% of the building, but it's absolutely true, and it adds up very, very quickly. And so I've been on hundreds and hundreds of site visits across all of our customers, and every single time, every single facilities manager says, no, there's no waste here, we're highly optimized, everything's been sorted out. And then we'll go into the sort of fire escape exit and walk up the stairs, and it's been heated by all these sort of radiators as you walk up. And they're like, oh, I didn't know they were on. We should turn those off. How do we turn those off? And it's like, well, okay, hang on, there's a problem here. And the radiators are obviously a massive issue. Other people as well, where they tried to ban putting heaters under desks in office spaces. We can obviously set limits on wattage, and the sockets will turn themselves off if it's got too much wattage running out of it, like a digital fuse, without having to damage a fuse that requires replacement. Other advantages as well are, because obviously we manage the power on that kind of granular level, we can detect things that I deem to be more valuable than the money-saving aspect of energy, but it's difficult to quantify. And because we are measurable energy, everything we do is quantified. We don't guess about anything we do. Everything is data-driven, but there are aspects that are harder to data-drive, such as several use cases where we've discovered someone was heavily overloading a socket. So 16,000 fires caused in the UK every year, and the number one cause is overloaded sockets. So obviously, because we can tell what load you're putting on it, we can automatically turn it off. So we can detect when devices are overheating, we can detect when you've overloaded a socket, we can automatically turn them off for you. This is another big part of what we do as well. Another thing we can also do, which is, again, things we sort of discovered after the fact, once you've unlocked all this data, occupancy, which is a big deal. So occupancy sensing is a big sort of hot button issue in the IoT world, especially in commercial offices. We cannot tell you who is where at what time with any kind of accuracy, but what we can do is tell you how occupied your building is on average based on some pretty obvious statistics in hindsight. So we had a customer who was looking at expanding their office in the UK. It was a £12 million project, which is quite a lot of money, because they had an office that could fit 100 people or so. They had 120 employees, and so from their point of view, it's a Canadian-based company. This is too small an office, so they started expanding the project. But when we looked at the data that we had, because we were installed in their building, we basically made the assumption and said, look, we're on every single desk in your entire office, and we're going to assume if the monitor is on and you have a laptop plugged in, we'll just assume someone was working there that day. And we just ran that for a month, and we discovered that the average occupancy was about 20%. So there really was no need to expand the office. So as far as I'm concerned, we saved them £10 million. They didn't agree, so it was difficult to justify that. But again, it's the same thing. Fire prevention is a big deal as well, because you could make the argument if you let that overheating socket go longer and longer and longer, could have caused an issue. But yeah, so having access to all this data gives you massive amounts of ancillary benefits, but we can't quantify those. So I leave them as like a little fun case study I tack on the end of things. So our primary driver is energy savings. So yeah, running since 2018, we've gone through Series A investment last year to expand. So we're now not so much a startup as we are a scale-up. So we're 30 people strong, based in Reading. We're expanding internationally this year as well. We're going to the EU market, which is going to be fun, because they have different socket standards all over the place. So the hardware has to change subtly for it. We're looking at expanding to the US next year as well. And another sort of easy win for us is trying to go over to sort of ex-UK colonies, which have the hangover of using the same plug as we do, which is an easy win for us because we can pop over there. So that's your sort of Southeast Asia's, Middle East. So we're going out there as well. Again, everyone has the same problem, with the exception of the Nordics by the looks of things, because their energy is so cheap and so green, the business case struggles more. But those ancillary benefits though, yeah, I just have to learn how to speak Swedish and then I'll crush it, yeah. So I think that's everything from me. Yeah, so simple, cost-effective, scalable way, decarbonising your construction project or your commercial real estate. Happy to take any questions, get in touch anytime. Yeah, thanks very much.